today we're going to be talking about our newest chapter, which is going to be chapter 6. And this is going to be about functions, and we're going to look at some specific functions. But first, we're just going to review some of our function operations. Now, these operations are going to be very similar to what we did with our polynomials. And the only difference here is going to be kind of what they look like, or our notation. So notice that we've added in a function notation. So hopefully we've seen f of x and g of x and different types of functions like that before. Here though, we're going to be combining them with operations. So we have f plus g of x. And what's nice is that whenever we're adding two functions, if we know what those two functions are, then we can just add them separately. Same thing for subtraction, multiplication, and then the only thing with division is, just like always, our denominator can't equal 0. So whatever function is in our denominator can't equal 0. So let's look at some examples of this. So it says given f of x equals x squared minus 4 and g of x equals 2x plus 1, find each function and then indicate any restrictions on the domain or range. So just like from our previous page, it told us that if I am just adding two functions, then we are allowed to just separate that into f of x plus g of x. And the reason why that's nice is because if we know what f of x is, which in this case is x squared minus 4, and we know what g of x is, which in this case is 2x plus 1, then we can just add the corresponding terms. And this is the piece that's really similar to what we did with our polynomials. So notice that I have an x squared, it doesn't have any like terms. I have a 2x, it doesn't have any like terms. So the only part that has like terms are the constants. So then we just add. So we have x squared plus 2x. Then we have negative 4 plus 1 gives us negative 3. Our subtraction is going to work very similarly. So we can separate out our subtraction. Again, replacing our x squared with what our directions tell us it is, and replacing our g of x. Now again, our only like terms are still the constants, so we still have x squared, but notice that we're subtracting all of g of x, so that negative has to apply to the 2x, which makes it negative 2x, but it also has to apply to that 1. So we have negative 4 minus 1, which is going to give us negative 5. A really common mistake that I see is that people just subtract that first number, but they forget to apply the negative to the second number. So just make sure that you apply that negative to everything in that g of x. And because all of these are polynomials, for the most part, I'm not really worried about what our range is going to be. I just care about restrictions on our domain. And since all of these are polynomials, there are no restrictions, which is nice. So let's look at a few more examples. So in this one, they give us f of x equals x squared plus 7x plus 12, and g of x equals 3x minus 4. And we're going to find each function. So to start with, we have multiplication. And again, just like with our addition and subtraction, we can separate that out into be two separate functions in multiplication. And again, I'm going to plug in what we know our f of x is given to us as, and then what our g of x is. And then we're just going to be multiplying. So I have to multiply everything in my first parentheses by everything in my second parentheses. So we have x squared times 3x is going to give us 3x to the third x squared times negative 4 gives us negative 4x squared. 7x times 3x gives us 21x squared. 7x times negative 4 gives us a negative 28x. And then moving on to our 12. 12 times 3x gives us a positive 36x. And then 12 times negative 4 gives us negative 48. So again, we want to look for our like terms. So notice that I have 2x squared. We have 2 x's. And then we have an x cubed and just a constant, but those don't have any common terms, so those are just going to stay the same. So we end up with 3x cubed. Then we have a negative 4x squared plus 21x squared. So we end up with positive 17x squared. Then we have a negative 28x plus 36x. So we end up with a positive 8x. And then we have negative 48. We don't have any other things that we can combine, so that's going to be our final answer. And we do not have any domain restrictions. Alright, and then now we have an example of division. So again, we're just going to separate our two functions using whatever operation we're doing. Then we want to substitute in the functions that they give us. And really, that's going to be our answer. The only thing we have to worry about is that g of x. So remember, we said from the beginning that our g of x, or whatever is in the bottom, cannot equal 0. So for this problem, that means that 3x minus 4 cannot equal 0. But we don't want to leave it like that. We want to figure out what x value specifically would make that whole thing 0. So notice that I can solve this just like I would normally. And so we get that x cannot equal 4/3. So then we just want to add that to our problem. So basically we're saying that x squared plus 7x plus 12 all divided by 3x minus 4 is my answer as long as x does not equal 4/3. And that would be the domain restriction, which we listed there. So that would be our final answer. So those are our first 4 main operations, and we've dealt with those types of operations before. But we actually have a 5th type of operation that's going to be new for our functions, and that's called the composition function. Now, our composition function is a little bit different because what we end up doing is using the results of one function to evaluate another function. So what we're doing is we're going to plug one function into another. So we can see this a couple of different ways. The first is that we will see f composite g of x. So it kind of looks like a multiplication symbol, except it's hollow. Okay, and this means the same thing as f of g of x. So I'm plugging my g into the f. Okay, so please, 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 please realize that this is not multiplication. Okay, because that's the biggest mistake that I see with this operation is that people just try and multiply, and you cannot just multiply. So the way that I like to help people think about it is using our turducken, which is what is listed right here. So a turducken is a duck inside of a chicken inside of a turkey. So we have these different layers, and basically they're stuffed. Instead of stuffing, they're stuffed inside of each other. And the reason why I like to use that kind of as a metaphor is it kind of paints this picture for us. So my innermost layer, okay, or my chicken, which is the smallest one I believe, is like my X. And it's on the very, very inside. And that gets put inside of our duck, which is like our G of X. And then both of those together get put inside of our turkey, which is like our f of x. So they are being put inside of each other. Over here on the right-hand side, I have another way of kind of looking at it. So we have all of these x values in our first circle. We're going to put those values into g, and that gives us our second circle, which are going to be our y values, or the range of g. And then those are the values that we end up plugging into f. So the range of g, or our y values of g, become the x values of our f. So let's look at an example of kind of what I mean. So this says, find the composite of each set of functions. So we are wanting to find f composite g. And like I said, this turns into plugging g into f. So just like before when we were doing our other operations, I want to replace the inside function with what they tell us g is. So they tell us that g is for a. So now we have f of 4a. And we've looked at examples like this before, so remember that we can evaluate a function at numbers, at variables, or at expressions. So here we're evaluating f, or we're going to plug in for f for a. So what's going to happen is anywhere that there is a variable in a, or in f, it's going to get replaced. So notice that I have this a here. So that needs to get replaced with a 4a. So basically I'm copying the 4a and I'm going to paste it on top of my a that's inside my f of x. So what that becomes is 2 times 4a minus 5. Now notice I didn't change the 2 on the outside because I'm not replacing the 2. I'm just pasting in for the variable that's in f. So then I'm just going to simplify, and that becomes 8a minus 5. So now let's look at another example. So again, we have f composite g of x. And this is going to be f of g of x. So again, I'm going to replace the inside function with what they give us, which is x minus 6. And again, we want to look at, okay, I have an x in my f of x, so that is what's getting replaced with the x minus 6. So I'm copying my x minus 6, I'm going to paste it into that variable spot for f of x. So it becomes x minus 6 squared plus 2. The squared doesn't change and the plus 2 doesn't change because I'm just pasting in for my variable. And then we need to simplify. Be careful here because remember that we are not allowed to distribute a squared. So if we needed to remind ourselves of what x minus 6 squared is, we could come over to the side and do some scratch work. So remember that squaring something means that I am going to multiply it by itself. And then in this case we would be able to FOIL it out and we get x squared minus 12x plus 36. And then we still have that plus 2 on the outside. So then our last step is to combine any like terms. So our only like terms are going to be that plus 36 plus 2. So we get plus 38. So again, some key takeaways with our composition is 1, this is a new function. It is not multiplication. Okay? And 2, we are plugging into our other function. We're going to replace our other function with whatever's on the inside. So for both of these, they had variables. But sometimes we can have ones that are just numbers as well. And it still works the same way. So again, remember I want to replace my inside function with whatever it is, or whatever number I get. So notice that I know what h of x is, and they tell us this time that we want h of 3. So I'm going to come down here and I'm just going to find h of 3. So just like normal, when I evaluate, I'm going to replace that 3 into any of the spots that I have in x. So I get 9 plus 18 plus 8. Adding those all together, we get 35. So then now that we know what h of 3 is, that means that we can replace that inside with what we know h of 3 is, which is 35. And now we can evaluate that because we know what g is. So we can say, okay, I have an x times my negative 2, so I'm going to replace that with my 35, and then I have a plus 1. So negative 2 times 35 gives us negative 70, plus 1 gives us negative 69. So that would be our answer. We always want to start with the inside first, figure that out, okay? And then we're going to plug whatever we got into our other function. And this works, like we've looked at, with both numbers and expressions.